We are going to finish up our review for our Chapter 9 test today. Question 12, it says use the given information to write an explicit geometric rule and then find a sub 6, or the sixth term of our sequence. So we are asked for an explicit geometric. What is the basic formula for that? Explicit geometric. Okay. So to find the nth term, we're going to take the first term times our common ratio to the n minus 1 power. What we are given is the first term, but we aren't given r. We are given the fact that the fourth term is 6.25. Okay? So we can use that value to help us kind of work backwards and figure out what our r value should have been. So plugging in what we know we get 6.25 for an answer. When our first term is 400, we have some kind of common ratio. And what are we going to have for a power? 3, because we know that when n is 4, right, we get 6.25 for an answer. Okay, so step 1 would be to divide out the 400. So we are going to get a decimal. Go ahead and do this on your calculator and just keep that decimal number in there. All right. And then how do we undo a cube? Cube root. So take that decimal that you have in your calculator and take its cube root. What do we get for our value for our common ratio? All right. So 0.25, 25 hundredths. Yes? What's another way of writing that? 1/4. We could put it in fraction form with a 1/4 as well. All right, so now we can write our rule. We're going to dump that in. So a sub n equals our first term of 400 times 25 hundredths, or 1/4, to the n minus 1 power. Okay. Now we can use that rule to help us find the sixth term. So a sub 6 will be 400 times 25 hundredths to the fifth power. All right, what do we end up with? .390625, is that what it was? Okay. Now, does it make sense that we're getting a small number like that? Yes, we started out with a big number, 400, but we're cutting it by a fourth, right? We're cutting it a fourth of what we had previously. So our second term is already down to 100, right? Our next term is a fourth of that, or 25. So it's not unreasonable that by the sixth term, we are down lower than a 1. Okay. Question 13. It says use the formula to find the sum. So we are at the point now where we're shifting from finding nth terms or explicit rules for our sequence or recursive rules for our sequence, and now we're starting to look at summing them. Okay, so we're looking at series, where we add the numbers of our sequence together. It says use the formula to find the sum of the finite arithmetic series. Now, one comment before you do your test tomorrow. It says to use a formula. If I'm giving you a geometric or an arithmetic series where I'm asking you to add those terms together, you have to show me with formulas that you know how to do that. Okay? If I ask you to find the sum of a sequence that is not arithmetic or geometric, you don't have a formula for those. Our only way of doing that at this point would be to write out all the terms and add them up. Okay? But if it is arithmetic or geometric, you have to show me the formula that goes with that. So this one says finite arithmetic. Our formula for that, that's the one where we pair up our numbers. So we look at how many terms we have in our list. We pair them up, so cut them in half. And each pair is the sum of the first and the last term in our list. So of the things that we need to know n, first term, and last term. What are we given? We do know first and last. Do we know n? No. We know that the first term, second term, third term, fourth term, we're given those, but the dot, dot, dot doesn't allow me to count. So I don't know how many numbers are in that list. But I know that it's arithmetic, so I can work back and figure it out. Okay? So before we can actually plug things into our summation formula, we're going to have to find the n value. So we're going to go back to our explicit formula and figure out what our n has to be. Okay? Our first term was 9. What's our common difference? We're adding 4 each time? Okay, so adding 4 would be our d value. And we know that our last term, our nth term in this list, is 53. So we should be able to figure out what our n value has to be. Okay? Simplifying on the right-hand side, we have 9 plus 4n minus 4. That simplifies to be 4n plus 5. If I subtract 5, what do I get? So 48 equals 4n. That means n would have to be 12. Okay? So 53 is the 12th number in my list. All right? So now we can go back and we can figure out our sum of those 12 numbers. So we are pairing up 12 numbers. We're going to get 6 pairs, and each pair is the same sum. First term plus last term. Our first term was 9. Our last term was 53. Okay? So we have 6 times what? Okay, 6 times 62 is how much? Good. All right, agree, disagree, 372? Okay. So keep in mind that when they ask you to do a summation, you may have to go back and use one of your nth term rules, right, your a sub n rules, to find any missing numbers that you need for your summation formula. The next question is still asking us to do a sum. It's telling us that it is a finite series. Is it arithmetic or geometric, or neither? We look at our formula here, right? N cubed minus 1. If it's arithmetic, it has to be a linear formula, right? Things like 2n plus 5, right? An expression like that. If it is geometric, it has to be exponential. So you have to have things like 5 times 2 to a power. Your variable has to be the power, okay, for it to be geometric. What we have here, we have a power, but our power is not a variable. So this is one of those cases where this is not arithmetic and it's not geometric. They are asking us to sum how many different numbers? 5. We are starting with our first term, right? Going up to our 5th term. 5 numbers is not a lot to figure out. We're going to have to figure out those 5 numbers and then just add them up. Okay? So we're going to write down 1, 2, 3, 4, 5. We're going to figure out those 5 terms. What do we get when we put a 1 in? Well, our formula says take the 1, cube it, and subtract 1. What's 1 cubed minus 1? 0. Okay, put a 2 in. It says take the 2, cube it, and subtract 1. 2 cubed is 8, so we get 7 for that one. Put a 3 in and cube it. What's 3 cubed? 27. Subtract 1, we're at 26. 4 cubed? 64 minus 1. All right, and then 5 cubed minus 1 would be 124. All right, so grab your calculators. We're going to add these up. Now, you actually could add these pretty easily without a calculator, couldn't you? What's 7 plus 63? If we pair these two, we get 70. What if we pair those two? 124 plus 6 would be 130, plus the 20 would be 150. So we get okay. So if it is a neither, not arithmetic, not geometric, this is what I would expect to see. If it is arithmetic or geometric, I can't see what we just did here. Okay? You have to show me those formulas are being used. All right, questions 15 and 16. Use series formulas to find the sum of the finite series. Which kind is the first one? Arithmetic. It looks linear. Yes? Second one is geometric, right? Our variable is an exponent. And it really looks like a sub 1 times r to the n minus 1, doesn't it? They don't have to look quite that closely to our nth term formula. All right. Arithmetic. We are summing. How many numbers are we summing? 10. From 1 to 10 is 10 numbers. And if it's arithmetic, we pair them up, right? And now we need first and last numbers. How do I find those? Put a 1 in and put a 10 in, right? 1 is the first number they want us to use, 10 is the last number. So let's find a sub 1 and a sub 10. Our first term, if we plug a 1 in, we have 2 times 1 plus 3, so we get a 5. If we put a 10 in, we have 2 times 10 plus 3, or 23. So now we can dump those into our formula. 5 plus 23 is 28. 28 times 10 halves, or 5, is how much? All right. Question 16, you said was geometric. That's probably the more complicated of all of our formulas. So we have the sum of how many numbers? 7. All right. Our formula says we need the first number. I'll put it up here. First number times 1 minus r to the nth power divided by 1 minus r. Okay? Do we know r? In this example, what is my r value? 4. It's the piece that's being raised to the power, right? That's your r value. Your first term, be careful here. Always take the first number that they've given us, that lower limit, and plug it in. We're used to seeing it like this, first term times r to the n minus 1. So our first term should be a 3, but we could adjust the power in an equation that still might be geometric, and it wouldn't be as obvious what that first term is. So just get in the habit of double checking it. If we put a 1 in there, 1 minus 1 is 0. 4 to the 0 is 1. 1 times 3 is 3. So first term is 3, and r is 4. So our formula says we take the first term, multiply by 1 minus r to the nth power, in this case 7, divided by 1 minus r. All right, grab your calculators. Double check how you type that in. All right, total here, 16,383 for your sum. Okay. Our next set of questions says evaluate each infinite geometric series. Infinite geometric. Which formula are we looking at here? S equals first term divided by 1 minus r. Okay, now we said that we can find an infinite series, right? We can find the sum of it if R is what? The absolute value of R is less than 1, or R is bigger than -1, smaller than +1, right? Between -1 and +1. If R is in that range where the absolute value of it is less than 1, we say it converges, we can find a sum. If it is not, we say it diverges, and there is no sum. Okay? So the first thing I look for is, are my numbers getting smaller? As my sequence goes further to the right, are my numbers getting smaller? In the first one, are they? Yes. In the second one, are they? No. In the third one. And ignore the sign of it. Just look at the number part of it. Are they getting smaller? Yes. So 18 here, this is the only one where we're not seeing our numbers get smaller. If we tried to calculate a value for R, what would we get? Remember, it's always a term divided by the previous one, right? So 3 divided by 1, 9 divided by 3, 27 divided by 9, any of those? We're getting an R value of 3. That's too big. So for question 18, we're going to say it diverges. And I'm going to put none down for the sum. There's no way to find it. Okay? The other two appear to converge, right? Our numbers are getting smaller. We still have to figure out R. So take any number and divide it by the term before it. What's 32 divided by 40? 8/10. All right. We can put it in as 0.8 if you want, or 8/10, doesn't matter. 4/5. All right. So it is a value where its absolute value is less than 1. So we would say it converges, and we can actually calculate the sum. Our first term is 40. We're dividing by 1 minus 8/10. What's 1 minus 8/10? 2/10. 40 divided by 2/10. What's 40 divided by 2? 20. Okay. What's 40 divided by 2/10? Dividing by 2/10 is the same as multiplying by 10 halves, right? So we actually get 400 divided by 2, or 200. Okay. Question 19. What is the R value? All right. -5 divided by 20 is -1/4. Okay. How would it look if we left it as a fraction here? So we have the sum is first term divided by 1 minus R. What's 1 minus -1/4? So 5/4. All right. So we have 20 divided by 5/4. That's the same as timesing by 4/5. What's 20 times 4/5? 5 goes into 20 4 times. 4 times 4 is 16. So this one converges, and its sum is 16. Okay. Determine whether each series is arithmetic or geometric, then evaluate the finite series for the specified number of terms. I want you to look at how this one's written. It has the little ... there, which means that the sequence continues in that same pattern, right? But they have given me this. They're saying we're going to go out to 12 terms. We're going to chop this off. Sometimes they refer to that as a partial sum, the nth partial sum. So it's an infinite series, but we're going to chop it off after 12 terms and just add those up. So we've made it finite. Okay? So we have n being 12. Is this one arithmetic or geometric? Arithmetic, we're adding 6. All right, so arithmetic, our common difference is 6. What are the things we need to know to add up numbers in an arithmetic sequence? We need a first term and a last term. And we need to know how many numbers we have, right? So we need a sub 1, we need first term, last term, and n. So they told us n is 12. They've also told us that the first term is 4. They haven't told us what the 12th term is. All right? But we can go take a step back and figure out what that 12th number is. Okay? First term we said was 4. Common difference you said was 6. And we're looking for the 12th number. So a sub 12 would be 4 plus 11 times 6. 11 times 6 is 66 plus 4. So my last number, my 12th number in that list would be 70. All right. Now we can find our total. We are summing 12 numbers. We are going to pair them up since it's arithmetic. Our first term is 4, and our 12th term is 70. All right, so we have 6 times 74. What do we get? What did you get? 444? All right. Next example, arithmetic or geometric? Which one is it? Geometric. All right, it is finite. We are summing 9 terms. So in our formula, we need our first term, which is 5, times 1 minus the r value. What is r in this case? Negative 2. We're multiplying by negative 2 each time. Our power is 9. And then we have 1 minus r in the denominator as well. All right, grab your calculators. Double check that you are putting parentheses around the negative 2 that you're raising to a power. All right, what did we come up with? 855. Agree, disagree? All right. Our last question. For the summer, your younger brother wants to make a lemonade stand to earn some money at the beach. On June 1st, he sells 15 lemonades. On June 2nd, he sells 18. On the 3rd, he sells 21. So 15, 18, 21. Write an explicit formula to model the number of lemonades he sells each day. What kind of sequence is this? It's arithmetic. All right, it's asking for an explicit formula. First term plus n minus 1 times d. What of those pieces do we know? First term is 15. What's my common difference? I'm adding 3 sales each day. Okay. Distributing 15 plus 3n minus 3. So my rule, the nth term would be 3n plus 12. All right. Now it says, how many lemonades could he expect to sell on June 20th? What are they asking us to do? Find the 20th term. All right. So we have 3 times 20 plus 12. What do we get? All right. So your homework is to finish up the green packet. Right? We're also going to, before you leave today, look at some of those formative quizzes that you've been doing.